That's great. Okay, so let's get going. So my name is Dan Hillary, and today I'm just gonna give you a brief introduction to R. We're gonna look at a few different things, just to show you some kind of basic syntax in R so that you can get going and maybe you can learn a little bit more yourself. Before we go straight in, let's just I'm gonna go to the next slide and does everybody have R downloaded? Maybe you guys can message in if you don't. If you don't worry. There's a backup plan. What you can do is you can go to this link here, rstudio.cloud. RStudio is a company that basically makes tools to make working with R easier. And they have recently just launched this cloud service, which means that you can use R on the cloud. So it will come up in the same way as if you had downloaded it. It's just going to be nice and quick. So if you can, go first to RStudio Cloud. If this is assuming that you don't already have it downloaded. If you've already got it downloaded, don't worry about it. Okay. So let me see here. So, and once you do that, I'm going to ask you to install some packages. So for those who don't already have R, go set up your account on RStudio, on rstudio.cloud, and then take this list of packages and you can install this. I'm going to copy this into the chat so that way you guys have this. Just one second. Hey, Wedad, how do I get the chat in this? Oh, I got it. Great.
It should be in the bottom of your screen.
Yeah, lovely. Okay. Just going to type it in here. Okay. Oh, when you know there's a typo, 1 second. So there shouldn't be a space in tidyverse there for anybody who still needs to download. Another thing that would be nice to know, if you guys could message in if you have not used, so Ahmed, if you're installing locally, if you're installing or on your computer, it's actually going to take quite a while to download those packages. It could take maybe 15 minutes, I guess. So yeah, I wouldn't worry too much about that. For the moment, we're going to talk a little bit about R, and we're going to look at a few other things. So don't worry too much. Okay. So if anybody doesn't have any access to R, don't worry about that either. If maybe you can't get into the cloud service, you're still going to be able to see lots of stuff. I'm going to show you guys, and it's still going to be useful. After this, I'm going to send you guys an email with all of the code and some links to other resources you can use to learn more about R. So anyway, let's get back to the slides. So, okay, that's packages stuff. So first of all, let's talk a little bit about why we're here. First of all, I really, really love R. There's a lot of people who kind of are maybe not used to R, maybe they're more used to Python or something like that, and they don't really get why why you would want R as opposed to Python. I think that R just has a much better syntax. It's much more focused on data work. R was built for the purpose of doing data science effectively, and for working with statistics. And so for that reason, a lot of things are just much more intuitive. And I think it's a really, really great advantage. So I'm going to hopefully show you why I think that a little bit. I'm going to show you some very simple stuff to get you going so that you understand how to get started with R, so then you can learn more stuff yourself. And in particular, I'm also going to show you lots of ways to learn R yourself and how to basically do a little bit of almost debugging in R, and then give you those skills so that you can go off. And the next time you want to do something, you can just, work your way through it. And you can Google things and use other resources. I'm also at the end, hopefully going to show you some of the really cool stuff in R. There's some really, really interesting add-ons, packages, and things you can do that you can't really do as easily with other languages, like say Python. Okay, so a couple of the other things about R that's good to know. First of all, it's open source, which is great. It's free. Lots of other languages, say people might use, even Excel is not free. So a lot of other things in this world are not. Another good reason why to use R is RStudio. RStudio is a program that's built around R to make it easier to develop, and it is super. You guys should maybe have already installed it. It's a really useful tool, and you're going to see that a little bit of that too. On top of that, in academia for things like statistics and in lots of other fields, R is the go-to language, and a lot of important algorithms and contributions are turned into packages, and they're produced on R first. So you have access to really, really useful features straight off the bat. So that's great. On top of that, you have great visualization in R. So an awful lot of the graphics you'll see, even in newspapers, come through R, which is amazing. It comes through packages like ggplot2. It's far, far better than the equivalents in things like Python, at least so far, certainly better than things like matplotlib. There's other tools like R Markdown and Shiny. We might get time to show you those things. I'd love to show you those things because they are effectively ways to make reports and even apps with R, which is an amazing feature. But anyway, let's get moving. I'm going to move into R now because I think that's the best way that we can show you how to do things. So,
Dan, there is a question. Mariam got an error of non-zero exit status for tidyverse package. Any idea about that error?
Was there a space in between tidy and verse by any chance? I think when I sent the message, there was a space. So it might be my bad.
I'm not sure. Mariam, if you can answer.
Oh, yeah. Sorry, I didn't see the chat until now.
No worries.
Yeah. So usually a non-zero exit status is just a general way of saying the package didn't install. So specifically, I don't know what that might be. It could be anything. But even if it didn't, what I'd advise would be maybe try out going to the RStudio cloud and using it there. And if not, don't worry too much, because actually we only use it for a very small part of the course. So if you don't have the tidyverse, you're going to be able to follow along with the vast majority of it. Okay. So anyway, post in the chat if there's anything else, and yeah, if not, we'll move into R. So let me see here. So let me just get rid of this. Okay. So now, okay, can you guys see my screen and see RStudio in my screen, most importantly?
Yeah, it's clear.
Great.
Yeah.
Great. Okay, so very briefly, just going to show you RStudio. So in the top left-hand corner, if you guys don't already, you can see a little new file button. Click that, go to R script, and this will just open a new script for you guys. Below that down here, we have the terminal. This is where if you want to just type something directly into R, if you type it in here, it will run, right? So say, for instance, I mean, R fundamentally is a big calculator, right? So I could start off with something like this, 10 plus 3, 13, okay? So you can just type things into the console like this, and it will do all your computations. So the one problem with typing things in here is that when you do that, what happens when you want to change something, when you want to edit something, when you want to save something? So the best thing is to put all your stuff up here. You can do a comment with a hash and say, all right? So now let me just show you, first of all, some more of the operators we have, right? So obviously you have minus. If you wanted to run this line, you have a couple of options, right? So you can highlight the line, press run, just copies it down into the console and runs it. Or there's a keyboard shortcut of just having your cursor, your cursor on the line, do command return, and it runs as well. Okay. So those, anyway, you have all the basic operators you have. You have, also multiplication, which is the star. You have division. And generally, people like to put spaces either side of these operators. You also have, of course, if you wanted to put something to the power of, and this, so you have two options here. You can go 10 star star 2, give you 100, or you have, 10 with a little hat 2. Okay, so I'm just showing you a little bit of basic syntax. Everybody's following so far? Is everybody able to run things in the console? If not, just pop in a message and let me know. So you can also, of course, you can define things in R. So I could say that X is equal to 12, right? Now, when I do that, I just ran this command, this X is equal to 12. Nothing came up here because R knows that, like, if I'm giving it a name, I probably don't want it to print out anything. I just want it to store this value 12 and call it X, right? RStudio does the nice thing of over here on your right-hand side, it keeps a track of everything that R knows, right? So R knows that X is 12, right? There's another option for this. I can also do Y is defined as 12, right? So this is a special operator to R. This little less than sign and a dash. It's exactly the same as the equal sign. They cause the same thing, right? So now we see that Y is also 12, okay? And while we're here, we can ask R if X and Y are the same, right? And the way we do that is we say X equals Y, right? This equals, double equals is a test for equality, right? And so what it does is it prints out whether or not that's true or false, okay? So one of the really nice features of R is that it's vectorized, right? And what that means is that we can do a lot of kind of calculations without having to like explicitly run through each thing in a list or each element. And I'll show you a little bit more about that. So first off, we're going to write, we're going to make a little set of data. So we're just going to put some ages here, okay? I'm going to write C, open bracket. I'm just going to do some random numbers. You can put whatever you like. Doesn't really matter. Right? This operator is super important in R. This little C. This is how you make a vector, okay? Anything inside this will be part of a vector called age, right? So we're going to run this. And now we see up here in our values, age is a numeric vector from length 1 through 7. And it's saved in R, right? So we can also do another vector. I'm just going to call, say, Tyler. I'm just going to give some names. And so here when I'm doing names, because it's a character thing, I have to put these quotes around it. I can use single quotes or double quotes, it doesn't matter. But I can't just type, say, like this, because I'll get an error. Why? Because when R looks at something like this with no quotes, it assumes that it should already know what this is, right? So it should know that, like, Rachel should be up here somewhere being a value. Whereas here, that's not the case. We're just saying the word Rachel, not like some value R should know, right? So I want to make sure I have the same number of names as ages, and I do not. So let's stick in another one. Okay. Some very simple little functions you're going to need to know. Length. Let's check that I do have the same names as ages. So that's 7 for the number of names.
Then, just to make sure, C is a list or array?
Say that again?
C, the variable C,
oh,
is a list or array?
There's no variable C. So the C is actually a function, right?
Yep.
So this is equivalent to like a tuple in Python. It's called a vector. And so in R you have vectors and lists. We'll get back to this, but you have vectors and lists. This is how you make a vector. And one of the important things for the programmers out there to know is that vectors have to always have the same type. So you can't mix up characters and numbers in the same vector. But we're going to talk about that later on too. So does that answer your question?
Not sure, because Hassan Jaber asked, yeah, he said yes.
Okay. Yeah, but the important thing is actually, that's one thing that's a little weird. C here is a function. It's just saying that put all of these things into a vector, I guess. Yeah. Okay. So anyway, we're good with the length of these two things are the same. So now what might be useful is how do you actually pick out things for these items. So if I wanted to know what the 6th name was, I would go name, square bracket 6. For people who might be familiar with Python, pandas is the pandas package in Python is based off R syntax. So you'll see some variables here. And in fact, pandas is basically a lot of R, base R that was translated into Python because it was so useful. Anyway, some other little subsetting things we can do is, say if you wanted to get the last thing in the last name in the list, or the vector, I should say, then you can just do name, copy that in there, and out pops the last name. All right. And finally, say if you wanted to ignore some names in the list, you can go name, and say you don't want the third list, the third name. Apologies. You want everything else. Then you just do a negative sign. And this negative sign says, "Give me everything except for this index," right? Okay. And one more thing in this is, if you want things like, say the numbers between 1 to 10, all you have to do is 1 colon 1 to 10, right? And that will give you the numbers between 1 to 10. This is super useful in subsetting because you can do things like name, square bracket, 1 colon 3 will give you the first 3 names in the list. Okay. Okay. So now let's try and see if we can actually do something with these bits of information. So say I wanted the computer just to print out people's names and ages, right? What I can do is I can use the function paste, which sticks together parts of different vectors and prints them. And I could just put in what I want. So I can do paste the person's name, the word is, and then we'll do their age, and then sold. Okay, if I do something like that, out of the bottom, I get these sentences stuck together. Okay. Right. So now, so this is interesting and all, but maybe it'd be nice to get something more like a data set, right? So let's add in another variable, another one of these vectors. We're going to make salary, right? Salary is, you know, again, I'm just kind of picking numbers. It's probably best to copy my numbers, and that way later on you can see that everything matches up, but at the same time it shouldn't make much of a difference. Okay, so say these are our 7 salaries for our people. All right, now we have, if you look over in values, we have age, name, and salary, 7 of these. And we can now use one of our most important features, which is a data frame. So data frames are a native OR object, so you don't have to call a package or anything. And let's call this data, a data frame. And what it's going to be is these 3 bits of information. It's going to be the name of the person, it's going to be their age, and it's going to be their salary. There you go. So now we have data. Let's print data. Another thing that's worth noting is that you can print things by either just typing the name of the object, and you'll notice that over in this panel here, data is now in this different section, right? Because RStudio is nice like that way. It separates things that are data sets from just vectors and other values. Anyway, if you want to print data, you can highlight it and just do control return. You can also do run here. The result is the same. And it prints out this nice little, almost like a spreadsheet of data. Okay. So the next thing we need to know is how do we actually access stuff in here? Well, what we can use is this little operator, the $sign, right? So the $sign in R is a way of referencing variables in your data frames, right? So if I do data $sign age, I get back exactly that age vector, right? If I do data $sign name, I get back names, okay? And similarly, of course, for salary. Is everybody following along? Is everybody happy with this? Yep. Okay. So the next thing we need to look at is, okay, what if I wanted to get the 3rd row of my data frame? That's pretty easy too. I can do data, square brackets, 3 for my 3rd row, comma, and then just leave this 2nd bit blank, right? So here, we're going to get the 3rd row, and we're going to get all the columns, okay? And with data frames, you always have this. This is how you subset. You do square brackets, and then something, comma, something. It's almost like a matrix in school. The idea is this. Which in this case is the age number 21, okay? But you can also do things like, say, get data 3, and then do salary. Right? And that will pick out the salary column for you, okay? This is all a little bit, I know this is the most exciting part of the course maybe, but it's just super useful. You're going to use this all the time if you use OR. And so,
Dan, before you close this one, There's a question about the meaning of levels you mentioned.
Did I mention levels? Okay, I was almost trying to avoid that actually but why not? We'll get into it. Level. So there are three main types of objects in R, or object types, I guess. There's character, there's numeric, and there's logical, right? But there are other types as well, which we kind of don't think of as main types, but they're types. So another type is factor, right? A factor is a character vector, or it's a character type, but the special thing is that there's certain levels of a factor, right? So if this comes from, like, if you're doing an experiment, say, right? And say you were using 3 different types of paint and you wanted to see whether people could see better with different types of paint. I don't know. I'm not a scientist. That you could, in R, you could encode that as a factor, which would say, this factor can take red, green, or blue, and that's it, right? There's no other, and if, for instance, you were to try to input orange into that factor, it wouldn't work, because it would say, oh, that doesn't fit. So in this case, with the data, in our set data $name, R automatically interpreted that as a factor, because prior to the most recent version of R, it will always assume that a character vector like this is a factor in a data frame. And so what it's saying here is that these names are the only names that you can have, right, for this data frame. You can add more separately, but the point is that, like, it expects these names. Does that make sense? Does that answer the question somewhat? I hope so. So yeah, so some people might have seen that when they actually do this, when they do data $name, that it doesn't come up as a factor, and that's probably because you have an R version later than 4, because factors are kind of they're kind of annoying, and they're kind of old-fashioned, and they just cause problems. So R decided to not have that to be the default behavior. That now the default behavior will just be to consider things like that as character vectors. Okay, so yeah, one last thing I want to show you about this subsetting is, like, say we wanted to ask the question, what is John's salary? Oh my goodness, I can't spell today. Anyway, not that it matters too much. So we go to our data set. We want to pick out John, so we want the name to be John. So we go data $name equals, double equals, because we're doing, because we want to check for equality. We're not telling it that the name is John. We're just asking it to pick out the ones where the name is John. And we want to know his salary. So there you go, out it pops. Yeah. So that's the subsetting of data frames. And let's have a look as well. So we're going to move on now to data types, which we've kind of talked a little bit about already, but let's just go through a couple of bits I have here to kind of wrap that up. So like you see over here in our in the environment pane in our studio, you have different data types and different objects that are kind of some of them are marked here. So for instance, you could do data. So data itself is a data frame, right? If you're not sure, you can use the str or structure the function, which will tell you a little bit about what an object is, right? So here, when you type str data, it tells you, first of all, it's a data frame. It has 7 observations or 7 rows, 3 variables, right? It tells you the type of each of these rows, columns, right? So the first is name. It's a factor with 7 levels, okay? And on that like factor level thing, one of the big differences between factors and character vectors in R is, and what was particularly important before was that it would basically assign a number to each level, and then it would just basically have a connection between the name and the number. And for computation, this made things easier because it didn't have to check the characters, it could just check the number. But anyway, so the name here is a factor, age is a numeric, and salary is also a numeric, right? Yeah, okay. So we can also do the structure of, say, X that we made earlier. It's just numeric 12. We could do a structure of name, the vector that we started off with, which is a character vector. And that way you can tell straight away. Another type would be, for instance, say you wanted to check which salaries were under a certain number, say 8,000, right? If I run this statement, it gives me a sequence of trues and falses, right? Because it's basically taking the salary vector, which, to remind you, looks like this, and it's saying this is less than 8,000, this is less than 8,000, this is less than 8,000, this is not less than 8,000, so on and so forth, right? And you can save this object if you want as an OR object in the same way. And when you run that, it pops up here, and you see here it's a logical vector, right? Because it's just trues and falses. So that's another another important data type. Okay. So let me see. You can also check things. So for instance, say you're not sure what type salary is, right? You could ask, or is logical salary? And it will say no. Is character salary? Nope. Or even is numeric salary? Yes. Okay. So anyway, now that we've gotten that kind of out of the way, we can do some more fun stuff, right? So now we're gonna import never mind that. We're gonna import a data set, and we're gonna play around with that. Okay, so anyway, this might be a good time. Is there any other questions you guys have? Anything else you'd like to get clear on, I guess?
Okay, Dan. So there are two questions. One, getting closer. Let me check it again. Object of type closure is not substitutable. I'm not sure if I say it right.
Yeah. It probably so okay. This is actually a good question. I'm not exactly sure what happened, but probably what happened was that data. So okay, let's go through this, right? So data is, and we already said is a data frame, right? And actually, so we know it's a data frame, right? Data $age is a vector, right? So even though it's like it comes from a data set, right? And even though it's kind of just part of this data set, it itself, unlike some other languages, it's not a data set, right? It's exactly the same as the age vector we started off with, right? So probably what your error is there is that you're doing some kind of an operation like, say, salary or something, or sorry, where you're like something like up here, right? You're doing something like this where it's appropriate for a data frame, but it wouldn't be appropriate for a vector, right? Well, that's not. Let me try something like this. Well, anyway, so that's maybe an important point, is that when you do when you subset like that, when you choose a variable out of a data frame, it becomes a vector. But anyway, if you could post also what exactly you put in, then maybe we can figure out exactly what went wrong. Yeah.
And another question, if we can apply a drop level function to that columns, like to data name, data age, and still keep the data frame structure.
Yes, I think so. Yeah, there will be no problem with that. And in fact, why don't I show you guys, if you go back up to where we define data, you can also do this thing, string as factors equal to false, right? If you have, like I said, if you have versions of or greater than 4, this will default to true. But in that case, then when you run that again, if I run data, I should do str of data. I hope everybody's following that. Then name is a character vector. It's not levels anymore. Yeah, I haven't used drop level in a while. Let's see what happens. Drop levels. So if I do drop levels, oh well. See, now I've messed it up because let me just take this out again. Define this back the original way. Let's do drop levels of data. And I'll save this as data. Data. Do str. Interesting. Right. So this is actually a great time. So when I ran that, it didn't drop the levels in the way I thought it might. So let's find out more about the drop level function, right? So if you can look in the console here, I'm going to put a question mark. I'm going to put drop levels. And this is really useful, right? Say you have a function, it doesn't work the way you think it's going to work, or you're not sure exactly what's supposed to go in. You can use this question mark before the name of the function, and then it will come up over here, right? So, interesting. Yeah. So this will tell you why I was wrong, which is that drop levels doesn't get rid of levels completely and turn it into a character vector. What it does is it looks at your data set, and if, for instance, often if you had a big data set, say, with 1 million rows, and then you decided to subset those and you took 1,000 rows, right? When you take that smaller data set, R will still remember the factors from the 1 million rows, right? So you might have names as factors. You have 500,000 different names, and then when you go down to your smaller data set of 1,000, you're still keeping these 500,000 possible factors, and actually you don't even want that. So apparently what drop levels does is it gets rid of anything that's not present in your data set. Okay, great. So that's just a good way to check that you're right, because I was wrong on that one. But question mark before a function is super useful in R, and R has great help, especially R Studio. It's great kind of help here. Okay, so yeah, okay, let's get cracking anyway on getting the data in. Okay, so let's see. So the first thing is we're going to need to pull in a package, right? And the package is a super useful package called Rio, and it makes doing all of this so much easier, right? So let's see. So we're going to do library, Rio, and actually you don't actually need these. You can use the quotation, but you don't need them, right? That will load up the library Rio, right? Rio stands for OR input output, and it makes the whole process a lot easier. So I'm going to do Rio. Oh, sorry. I'm going to do my new data sets. I'm going to call it airport data. We're going to define it as being import. And I have a long URL, which I'm going to type out here. And let me see. Well, I guess I shouldn't do that. So let me hang on for a second and let me open up the browser so I can get it. Yeah, I can get this. Okay, all right, I'm going to copy this into the chat. This is just the easiest way, rather than having you guys download data sets and do all of that. So we're going to use import, and we're going to copy in this, this URL. This import function is great. This Rio package is great. It automatically figures out your the type of the file, basically by just looking at the file extension. And it can download from, it can take all sorts of different types. It can do, obviously, things like CSVs, but also more unusual ones like SPSS. It can even, I think, download from Google Sheets directly and stuff like that. But here we're going to use it to download from the internet of this CSV that has been posted, right? And that's going to get us our data. And that should load up. So let me know if you guys have any trouble with that. It's just downloading for me now, and rather slowly. I wonder why that is. Let me check my oh no, it's in. Okay, so great. So now we have imported our data set. And if you look in the environment pane again, you have airport data. We can actually click here to bring up what structure effectively it has. And we can do things like we can do head of airport data. And it tells you roughly what's in this data set. So this is a data set I came across. What it is a list of all of the airports in the United States, including their time zones and their altitude, latitude, longitude, names. It's just something to grab so we can kind of play around and see how data sets work in R. And it's fairly straightforward. So one of the first things I want to show you is this really handy function called summary. Right, so summary of airport data gives you some details on what's actually in the set, right? So it takes each of the variables, and depending on what the type of variable, it tells you whether statistics, descriptive things on it. So for character variables, all it can do really is it gives you the length, and it will also tell you if there's missing values or something like that. For numerical variables, it gives you this this set of numbers. So it gives you the min, the max, the quartiles, and the mean for each of those. So that can be super handy. You really want to do that to look out for outliers in particular and data mistakes. And that's kind of the first thing we're going to do with this data set, because I think it's worth looking at. So if you look at this, right, if you look at the longitude and the latitude, latitude seems fairly reasonable, right? It goes from 19 all the way to 72. Sure, I don't see any problems there. Longitude goes from negative 176 up to 174, which seems strange. We don't, my understanding is there's no part of the US on the other side of the date line, but there might be. But anyway, it's worth knowing, right? Time zones similarly. We have this time zone with a positive value 8. So yeah, there's some data cleaning needed to be done here. It might not necessarily be wrong, but it's going to skew things if we don't kind of if we don't check it out. So how can we do that? So first of all, say we wanted to ask something like, which airport is furthest west in this set, right? We could do airport data. All right. We'll do which and which is a great function. What it does is it takes in some logical expression, which we're about to type, and it gives back the index of the particular observation that has that. So once I type this out, it'll make more sense. So let's see, which airport data, again, $, longitude, is equal to the min of airport data, $, longitude, right? So what I'm asking you here is which is the smallest of these numbers, right? Min of longitude meaning, or should it be max? Well, which is the furthest west, right? And it tells me, okay, the answer is ADTECH Airport in Anchorage, Alaska. If you look that up, you'll see that it's very, very far west. So yeah, okay. Next thing we could do is we could look a little more into why that those numbers were a little strange. Why was it that the longitude numbers were a little off? And see, like, for outliers, how many we have, right? So what we can do is, we can plot very quickly all of the different values for longitude for the airports. And you see that the vast majority of them are all around here, between, like, say, 170 or sorry, negative 170 and negative 80, I guess. And there's a few which are not. So let's see what those few that are not, what's the story with those? So we do airport data. And now we want to pick out, so think about this one before I'm going to type it out, right? I want the airports where airport data, $ longitude is, oops. If I look over here, I see that it's a 0, right? Something that's often forgotten is you need to put a comma in here because we're just filtering on the rows, not the columns. Okay, so these are the 4, right? And if you look up these airports, which I actually already did, you will find that they are not in, they are not actually where, like, they're not towards Asia or anything like that. These are mistakes, right? So these longitude numbers, most of them anyway, just should have negative signs in it. It's a data error fairly clearly, right? So what I'm going to do instead of, now you could go and you could do some research, a good data scientist would, to see what the number should be. I'm just going to leave them out right now. So I'm going to say, I'm going to make a new set. Airport data, no outliers, and I'm going to call it to be almost this, right? Except I want it to be less than 0. Okay. So now, one last thing that we could do is we could look at, well, where are airports in the US? Right, so I could do a plot, and I could do plot. I want to plot on the x-axis. I want to plot airport data, $ latitude. Wait, which is which? Longitude. Yep. And I can do y is equal to airport data, $ latitude. Okay. And if I do that, interesting, I get something that's a little bit like the US, but what happened here? The problem is I didn't use this data set with my no outliers. I used the other data set. So let's stick in this. Get this right. And now I get a little map of all of the airports in the US. And as you can see, they're kind of everywhere. I guess Hawaii's down here, Alaska's over here. So yeah. Okay. So let's see. I guess time is flying by. I always think I'm going to get more done. We're going to go back to the slides and we're going to have a look at a few other things in R. Now that you guys have maybe gotten a little more comfortable. Yeah, so let me open that up on my screen. Oh. Oh, I see there's a little question here. Install and require. Yeah, that's a strange one. I don't know why there's no. Did you get just check for that one if you got anything like the earlier message, which was exit non-zero exit status in the output, Miriam, and that might help. Okay, let me share the screen. Okay, share. Okay, I hope everybody is back to slides. Yeah, Miriam, just on this one, I think, so Rio is actually a package full of packages. So it might be that one of them, one of the packages that Rio pulls in also didn't work. What I would try instead is try to see if you have, try the function read underscore CSV. Let me type this, because that's another one that will work here. The nice thing about Rio is that it works with everything, but read CSV should work as well. And you may have to do library of the tidyverse as well for that. If you don't have that, you can also try. I think read.csv. So give any of those a go, and hopefully one of them you'll be able to pull in the data. Okay. Yeah. Yeah. Oh, okay. Martin has a question. Okay, so what if I only want to plot the airports that have regional in column name? Interesting. So let's try that out. Why not? So let's see, regional column name. So first of all, I want to have a look in my airport data, $, name. Let's have a look. I want to see what this is. So they have all sorts. We're looking for the word regional, right? So what we want to do is we want to choose. Oh, I've just realized I'm not. Let me share my. Yep. Hang on a second. Where'd it go? Okay, now we're back. So airport data, and I just printed $name there, and we see that like some of them have this regional, right? So what Martin's asking is, how can we subset based on the contents of a string, right? And so for this, we're going to need a package. The package is called stringer, but it's in this tidyverse. So tidyverse is a package full of packages, and one of them is stringer. So I'm just going to load the tidyverse, which you guys should be able to get, right? And in the tidyverse, there's a function str. They all start str for string stuff. Str detect, I think. And I'm going to apply it to, and let's actually bring up the help for this. Str detect. Blah, 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 blah. So the arguments are string, pattern, and negate is something else. So let's do so that's the strings we're talking about. The pattern is just going to be regional. And we're going to have to do one more thing, but we'll just start off with this. So the other thing we need to do is that, okay, so this is regional, but it's all lowercase. So what I'm going to do is I think this is also a function. I'm going to make this input string also lowercase. How do I do that? Well, I don't remember how to do that. So what we're going to do is we're going to pop over to Google. I'm going to Google that, which is an important skill. And we can figure it out that way, figure it out together. So let's resume the share here. Oh no, hang on. So let's see. Okay, so I want to do lowercase in stringer. That's the name of the pattern. Okay. String 2 lower. Great. Okay, let's head back to R. And we'll do that. Okay. String, where was I? 2 lower. So what this is going to do is going to take all of these names. It's going to make them all lowercase. Then it's going to check if regional is in those names, right? And it's going to give me out this super long true or false vector, right? But the nice thing is, now we can go and we can do airport data. Oops. And we can subset. Right? So this is, we're subsetting on the rows by this true or false vector based on whether the airport name has regional in it, right? And we get all of these, right? And so now we could either call this something, let's say regional airports. Let's just make that a thing. And generally speaking, R is not going to copy the entire data set. It's a little cleverer than that, but anyway. So let's do this little plot again. Okay, so we plot it the same way. Just going to change the data set name to be this. We might still have outliers here, depending. I don't know if they're regional. Yeah. So there you go, and you still get a little bit of an America shape. You get a little Florida down here, a little Texas, but you can see there's much fewer of them. Ooh. Okay, so let me just plug in my laptop before it dies, and then we're going to head back to the slides. So let me do that.
Okay, so then you have a question of filtering in the plot function, because I think in Python we can filter when you are plotting, but is it the same for R?
So yeah, let me just plug this in for a second. So one of the big things with R, and one of the things we haven't kind of gotten to yet, which is important, is that even though I'm showing you all of the base, like built-in stuff here, but like in say Pandas, there's a whole suite of tools that actually make filtering and make plotting with filtering much easier. So to answer your question, I would say like for the function I showed you, the plot function, that's super useful if you're doing exploratory data analysis and you just want to plot something. But if you want to do something more specific with plots, you probably want to start using the tidyverse set of functions, which is a way to kind of slice and dice your data in a much more efficient, much clearer way. So I don't think there is a specific filtering function in plot, but let me show you. Let me show you guys. I'm going to show you guys something a little bit different that I worked on this morning. That will give you an idea of what you can do. Let me see if I can do this. Give me 1 second. Yeah. So yeah, let's see if I can. Okay, so I guess a lot of you guys are probably programmers, so I'm not going to actually bother spending any time on like on the details of this functions and for loops and that sort of thing. But I am going to show you the syntax, and then I'm going to get back to your question on the filtering. Okay, so the syntax for making a function is effectively you get the name of the function, equals or defined as the function, its inputs with round brackets, then curly brackets, you do whatever you want to do, and you're done. Okay, so this is very similar to Python, except curly, well, I guess it's not that. There's curly brackets, and we do, also in OR, you don't worry about indenting or anything like that. Also for if statements, right, it's if the condition, which obviously is like a logical expression, in round brackets, and then curly brackets, and then and else in the same way. So I'm rushing through this because I think that like a lot of people already kind of know this, and it's very easy to look up. So similarly for like control loops, you have your for loops, your condition. So here, this one is saying like for the number I in between from 1 to 10, print I, and the while condition, same thing. Whenever this condition is true, you do whatever, say print the output. An important thing to remember about OR, and that's weird, is that the indexing starts at 1, right? So most other languages like Python say the indexing starts at 0, but in OR, the first element of a vector you would subset by like the vector is square brackets 1. Okay, so let's see. Okay, so this is what I wanted to skip on to because I think it's super interesting. And this answers the question of like subsetting and filtering and doing that in a nice way. So the tidyverse is a set of packages that were built on top of OR, and they're maybe like, they're not more than 6 or 7 years old, I guess. And they were built with the explicit purpose of making OR easier to read and write, and avoiding a lot of these like horrible syntax that you get when you try to like filter and group by and make new variables and all this kind of thing. And the principle is that, or the main part of it is this thing called the pipe operator, okay? So the pipe operator is this symbol here, this percent sign, greater than sign, percent sign. And we're going to see in the console, but the point of it is it takes data on the left-hand side and passes it to a function on the right-hand side. And you can chain these things up so that it makes all of these things easier to read and to do and to think about. It's one of the huge advantages of OR, I think. It's a big advantage I find of OR over Python, in that like it becomes clearer to read when you do this. So yeah, so why don't I show you guys a little bit of that? I think that's probably the best thing. And we can yeah, do that. So let me go back to where I was. Just want to make sure I wasn't skipping anything. Super important. Yeah, so actually, why don't we do this earlier analysis? We just like can rewrite it. And so you make, I see Martin's question, right? So this is the proper answer to your question, Martin, about like you can't just filter in the plot itself. The best way to do that is, okay, here we go. Let me. Okay, so we're back. You all can see my screen again. So yeah, let's try and do this in some nicer way, right? I'm going to rewrite this the way it should be and the way in practice I would do, but it's also, you know, you gotta walk before you can run, and it's important that you know the base of OR filtering because you'll use it in other places. So what I would really want to do will be, first of all, I wouldn't make this new set at all, right? I would take airport data, right? And I would use this pipe, right? This symbol. And I would say, take airport data, right? The first thing we want to do, well, we want to filter it, right? We don't want all of it, so we're going to use the filter function. And how do we want to filter it? Well, we want to do something with name, right? So we want to filter on name, right? Specifically, we want to do what we did earlier, do lower of name, and then we could, and we were also going to do this string to text. So basically, we just copy this out. In this case, and regional. Okay, and that filters it, right? And so this straight away will do what we wanted it to do in a nicer way, right? Because it says airport data, then filter it based on this. But we could also, you know, you could do intermediate steps there. I think that's probably the easiest way to do it. And now you can plot this into, you can pop this into ggplot. ggplot is another package for plotting. You might have heard of it. It's the best plotting package going, if you ask me. It's a little bit more complicated, and there's going to be another course on that later on. But for right now, let's do this. So what you can do is you can take the data set, you can filter it, you can pass it directly to ggplot, and then there's a little bit of the syntax is a little weird, so I'm not going to bother going into it. And then oops. So we can do something like this, right? And so there, this is like, to me, this is a much nicer syntax. First of all, you haven't defined anything new, right? You haven't changed anything. You've just said, take airport data, filter it based on this condition, and it's going to be a point. We want a scatter plot, effectively. One of the things you'll notice as well about this tidyverse expression is that up here, when I did this, I had to say airport data $name, right? I had to call it like this. But here I just call name. Because when you use this operator, it knows to pass the names of the columns directly. So you don't have to have these long, annoying, ugly expressions like up here. It's a much better syntax. So I hope that that helps. The tidyverse is a whole big subject in and of itself, but the important thing, I'm trying to basically give you some basics along with some pointers of like where to go to learn. And so that's the pointer here is actually more to, not that I'm going to teach you the tidyverse, but to learn about the tidyverse. The principle is, instead of having these nested functions, you go along in lines. Okay. So let's see, where are we going to next? So yeah, I think, you know, I have lots of other things we can talk about, but maybe this is a good time to start asking about other questions you might have. Maybe there's something else you'd like to go into more detail. I know we flew through a whole bunch of that stuff, and you know, if you want to ask me things like, you know, things you didn't understand, if you want to go back over something, or if you want to ask more things like about you know, how you can do other things in OR, you know, maybe now is a good time to do that. Yeah, okay, that's a great question. So I would say, well, first, so I think there's two parts to a good way to get started with R. I'm going to send you a lot of these things. The first thing is, it's, in my experience, it's always best to have some kind of a project or a purpose to learning R. And so the best thing I would say is, if you can come up with something. So for instance, when I first learned OR, I actually didn't like it at all. I learned some OR in my undergrad. I didn't see the point of it. I didn't see why I would like to know this. And so it wasn't until years later, when I was working on a project for fun on election data, just that I figured, oh, you know what, I need something better than just like a spreadsheet for this. I need to be able to like generate data. I need to do all these kind of things. And I rediscovered OR for myself, and it really was a lot of fun. And I think that's the first thing, is that ideally, you know, I wouldn't say go learn the tidyverse for the sake of learning tidyverse. I would say learn, you know, have something you want to do, and then Google your way through it is the best way. However, there are a good few resources, specific resources, that I think are great. And I'll email you the OR script. So the first thing that I just discovered the other day is a library called, well, let's go check. If you, over here in OR, we have this package thing, and I think it was with an S. So let's see. Anyway, I just thought it was super interesting and super useful for someone learning OR. So Swirl, right. So this is a good package to download. And let me show you how Swirl works, right? So we're going to do in the console. You don't have to do this in anywhere else, right? If you load Swirl, and then you just do this swirl command, SWIRL, right? It says, welcome to Swirl. And let's call, I already used this, I'm going to call myself Tom, because that way it'll give a new one, right? And what this does is, it is a little guided course on all of the basics of OR, right? And so you can play through this, and it will show you all sorts of different things, which I think is great. And so, yeah, so for instance, if I wanted to do this OR programming course, I can look at all these subjects. So for instance, say I wanted to look at simulation. And it'll go through piece by piece on how you do that. Right? So I think that's a great resource. The package is called Swirl. Another great resource, you know, I'm quite a fan of the online video courses, things like Udemy. Obviously, you know, never pay more than $10 is what I would say. But yeah, those are great. I also have some actual slides on this. There's also this course on RStudio Cloud, which is new. And then finally, if you have maybe, once you get to a certain stage, I would say there's a book by a guy called Hadley Wickham, which I've just sent you the link to. It's free, it's online, and that really gets into everything. Honestly, it's for me, that's everything you need to know for him to work with OR. There's more advanced stuff out there, sure, but that's what you need to know. It's a little bit more advanced. So if this is all new to you, I would say start off first with things like the Swirl package, and then work your way up. Maybe do there's a good Udemy course. Again, all of these things I can send you guys in links. And for data sets, let me show you one last thing before we go that I kind of discovered this morning that I think is super cool. So one of the, one thing that you can do with R is you can connect it to databases kind of directly. It's a little bit more of an advanced topic, but it's quite doable. And I did it this morning for connecting to Google's database system called BigQuery. And Google has this whole set of public data in BigQuery, right? And you can, first of all, you can just go onto their website and you can actually download the data for different things yourself from BigQuery. There's all sorts in it. It's really, it's enormous. And if you want to get really adventurous, you can actually do what I did this morning, which is I connected R directly to their database and downloaded the data directly. So I'm going to show you that right now because I just think it's super cool. So here, this is some code to connect to this particular database, which is on New York moving collisions. And it's a database of all of the car crashes in New York City. And it goes back a few years. So yeah, I connected this up. This tidyverse has this great system. So normally to query a database like this, you'd have to use SQL, which you might be familiar with. If you're not familiar with SQL, I think you really should give it a go. It's worth learning. You're going to need it if you're doing any significant data work. But one of the nice things about R is actually, in certain circumstances, you don't even need SQL to query these things, right? So here, I basically connected to the database. I said, I want this thing, NYC crash, to be my table that corresponds to this table of Google's, right? Google has this table of data, right? Which I won't show you right now, but you know, yeah, it's pretty straightforward, right? And actually, I can do, if I do NYC crash, let me just run this again in case it broke. Oh. I have to close Swirl first. Okay, so connection, making NYC crash a table, and once that connects, we should be good to go. So the point here is this will now become an object in my R session, right? You know, once it loads, and then even though I have not downloaded all of this data, it wouldn't be realistic. There's a bajillion rows. R still recognizes this, and you can actually treat this like a data frame in R, which is incredible. And you can filter it, and you can select things. And you can once I get this in, you can just plot directly from there. So this is actually, people don't realize this. This will be, for me, I mean, I don't see any obvious way to do this in Python. Maybe there is. But this for me is super. Like you can just take this, you can say this table that's up in the cloud, filter it, select these things, and then plot out these things straight away. You don't have to go querying things for SQL. So unfortunately, it looks like it's being very slow, but I will, I'll send you some links to that as well. So I'll put all that together later on today. Yeah. Yeah, I don't think that's gonna work. Any other questions, comments, concerns? Yeah, I'll definitely send you the R script, and probably I'll just send you a list of resources, maybe ranked by my favorites. Yep. I'm so disappointed with this big query. Oh yes, sure. So this thing, and this is, I'm very guilty of this, this operator. This is exactly the same as equal to, right? I think it's probably something that the clever mathematicians who came up with R and were not programmers thought was cool, and it's kind of stuck around ever since. I swap between the two all the time, and it's annoying for everyone else, but they mean the same thing. The only situation, and there's almost no situation, the only situation where you can't use them interchangeably is like if it's inside a function, And so you were saying like I couldn't have said like, you know, that earlier one, like when I was making the data frame, blah, blah, blah. Like I couldn't have said string as factors. Like I couldn't have said defined as. Let's say, just to make it work, defined as false. That's literally the only exception. Oh, right. Okay, so this is interesting. So what this has done is it's made up a new factor, or no, sorry, a new variable called string as factors, and made all of the values false. So no, you don't want that. So that's the only situation. You just want this to be equals, and then you're good. Okay. So yeah, I guess. Yeah. Let me see. Let me show you a few more things that I did want to show you. I was very worried we'd run out of time earlier on, and now we have plenty. So why not? I'm going to show you some of the really cool extra features. And you know, if you guys don't have time or anything, I won't be insulted if you guys have to go. So, yeah, this, by the way, is the book R for Data Science, which is super useful. I'll send you a link to. You can kind of, you know, it goes through everything, but it's not just coding, obviously. It's also, you know, the philosophy of how to do things and all sorts of interesting stuff. That will answer a whole bunch of questions. I use it. I read this. I flick through this book all the time for just finding out things that I need to know. I want to show you R Shiny because I think it's cool. R Shiny is for making apps effectively, kind of data-centered apps, and you can see them here. They're kind of they're publicly available, and so you can make these. These are not, I would say, particularly difficult to make. So this is something you can make with R, right? And you can host it publicly, and you can, you know, make, you know, do these different. I don't know what this one is, but you know, it's. I actually have made one myself for managing receipts. And all it is like a simple little drop-down menu thing where I put in like who paid for the thing, what project it's related to. It's just like for a side business I have. And it's on my phone. I can open it up my phone. I put in the details. I take a picture. And it goes off to a Google Sheet. It's super simple. It took me a day. And I have not used Shiny very much. So I just think, you know, can you do this in Python? Of course you can. But it's very kind of built. This is very like built into R, and it's very optimized, I would say, for R work. Let me show. So that's called Shiny. One more thing I want to show you is R Markdown, because I also love R Markdown. R Markdown is more for building like a report. So say, you know, in work, for instance, I often have to. I have an anomaly detector for the systems in work that checks to make sure that, you know, oh, we didn't accidentally break something or whatever. And the way it works is that every morning a report on the day's traffic before is sent to a Slack channel, and we can click through, and it just picks out anomalous traffic, and it shows you it in something like one of these documents. Trying to think of one, you know, something like that. I mean, mine is nicer, of course, but yeah, something like this. So this is something you can make in R. And again, a lot of the work of the design is kind of in formats, so you don't have to know any HTML or any CSS or anything like that. I love it. I use it all the time. Yeah. Let me see. Was there anything else I planned on telling you guys? Probably. No, I think that's good. Let's see. Oh. The book, does it cover business? I think somewhat. The book kind of covers some business intelligence points of view things. It doesn't have anything to do with Power BI for sure, but a lot of the time, you can. I don't know much about Power BI, but I'm sure there are ways to connect the two. So, for instance, if Power BI, I think has some kind of database part of it, I'm sure there's a way to connect R to that database and pull out all of the data and that sort of stuff. The book is mainly around modeling and prediction and that sort of thing, but and you know what? Even more than that, it's actually about like how to chop up data and find the right parts of data, which is great. So yeah. Okay. Very good. Well, I guess we'll call it a day. We'll send you all the details. Feel free to reach out if you have any questions. I love talking about R. I hope that some of this was helpful and the pace was okay. It's always hard to know. A lot of people are hardcore programmers who just haven't used R, and it's like you don't know whether they want to know about how to define a vector or whatever. But yeah. Anyway, feel free to reach out. There's also going to be, I think, 2 more of these based on R. So there's going to be one, which is a data visualization one, which I hope is going to be a lot of fun. And there's one going to be on time series. So yeah. Cool. Okay, well, I guess with that, we'll call it a day. Yeah.
Yeah, thank you, Daniel.
You're more than welcome.
And if anyone have a question, you can send me an email. You already have my email, and Dan will also answer your questions.
Yep, absolutely. All right. Have a good weekend, everybody.